Hey stats class, here's another example of a hypothesis test about a proportion. So we're setting up the null and alternate hypothesis, or just the setup of the test. Notice this time the alternate hypothesis is HA for alternate rather than H1. So those notations are interchangeable. A little subscript of 1 or subscript of A, you can see, and we'll see both. All right, but if you look at this question down here, or the statement that we're using to find the test that we're doing, this just gives us information about the sample. This tells us the significance level, and if you look at this, can you reject the claim? Here's the claim that 43% of home buyers find the real estate agent through a friend. There's no direction implied, so that's going to be a not equal to. So I'm looking at all the choices that I have here. There's only one that has a not equal to, and it's this one, but it also has equality in the null. All right, so that's going to definitely be the one. Okay, notice these that have inequalities in the null, like greater than or less than, those would be immediately rejected. These two, A and B, even though they have greater than or equal to, less than or equal to, they're still okay because they still have equality in the null. So sometimes you'll see them written that way, the null hypothesis. But in this particular case, because there is no direction implied in that claim, we're doing a not equal to for the setup. All right, let's look at the next one. What's the critical value or values? Right, it's going to be values, plural, because of the fact that this is a two-tailed test. So there's two critical values. All right, the way you find critical values for a two-tailed test is you're going to use this 0.02. That's going to be our area, but the area is the area in the tails. So this is actually going to be an outer with bounds. Okay, and we want the area in the tails to be 0.02. All right, that's a two-tailed test, so we select outer. If it had been a right-tailed test, we'd select right. Notice all the areas in the right tail. If we pick just left, all the areas in the left tail. But when we pick outer, watch the size of this left tail area. It shrinks because we give some of this area to this tail. We cut the area in half. So I have to go out a little farther in this case. All right, so these are our two critical numbers. It says to round these to 2 decimal places. So this is going to be negative 2.33, and then the opposite of that. So I'm going to do a negative 2.33, comma, and then a positive 2.33. All right, so the critical values are the region that our test statistic can't fall in between. It has to be beyond those. So this is a two-tailed test. This is just testing your ability to understand a two-tailed test. So area in both tails. That's what we're doing here. All right, and then our test statistic. Test statistic is the sample proportion, this 0.479, this 479 divided by 1,000. That's the sample proportion compared to the 0.43. Okay, so we're going to subtract the difference, p hat minus p, with this being p and that decimal being p hat, and then divide by the standard deviation. All right, p hat 0.479. Again, it's just the 479 divided by 1,000. All right, you could also have done that right there. 479 divided by 1,000. You could put that in the position where p hat goes. Minus the claim value of p. The claim value of p is 43%. So as a decimal, that would be 0.43. Right, and then on the bottom, it's the standard deviation. The standard deviation is the square root. Do a fraction next. And it's this value of p that we just subtracted, 0.43 times 1 minus this value. So 1 minus 0.43 is 0.57. If you don't know that, just go down to the next line real quick. Do 1 minus 0.47, or sorry, 43. And you see there's the 0.57 value. Okay? And then on the bottom, you're going to divide all this by your sample size, which was 1,000. So there's our z-score. Okay, this is just a z-score just like it was before. Measurement minus the mean. All right, the 0.43 is the mean of the sample means or sample proportions divided by your standard deviation. It's a z-score just like it was. That's why we're labeling it a z-score. And to 2 decimal places, that'll be 3.13. Now on the rejecting or failing to reject, you can just plot this point. You don't have to plot the point, but I'm just showing you can. If I did 3.13, comma 0, let me do it black so you can see it on the screen. There it is, and you can see it is in our rejection region. So we are going to reject, and if you reject, there is evidence. So I reject because there is enough evidence to reject the null hypothesis. Alright, so there is a hypothesis test about a proportion from the setup to the conclusions.